So thankfully there are explicit formulas. And an explicit formula will help you find any term in a sequence quickly, so you don't have to know the term that's directly in front of it like you do with recursive formulas. So if we look at the explicit formula for an arithmetic sequence, you need to know the first term. That's something you have to know for explicit formulas. You can use n to find the number of term that you're looking for, and d is going to be your common difference. So let's look at an example. So it says write an equation for the nth term of the arithmetic sequence 8, 17, 26, and 35. So 8, 17, 26, and 35. How can we go from 8 to 17? We can add 9. What about 17 to 26? Adding 9 again. Same thing, 26 to 35, adding 9. So we know that this is an arithmetic sequence. So to find the nth term quickly, we can use the explicit formula. So the explicit formula for an arithmetic sequence is a subscript n equals a1 plus d times n minus 1. Now in this case, what is our first term? Our first term is going to be 8. So a subscript n, because we're looking for any term, will be 8 plus our common difference, which is 9, times n minus 1. And that will be our answer. Alright, let's look at the next one. It says write an explicit equation for the nth term of the sequence 1.3, 3.8, and 6.3. So how can we go from 1.3 to 3.8? We can add 2.5. How can we go from 3.8 to 6.3? We can add 2.5. So this is going to be an arithmetic sequence because we're adding the same number to get to the next term. So the formula, the explicit formula for an arithmetic sequence, whoops, it's not that, is a subscript n equals a1 plus d times n minus 1. So what is our first term? Our first term is 1.3. So we're going to plug that in for a1. And what's our common difference? Our common difference is 2.5. So we're not looking for a specific term this time. We're only looking for the nth term. So we can leave it in terms of n. Now we can use this knowledge of creating explicit formulas to find any term in the sequence. So the number 4 says find the 50th term for the sequence 31, 24, and 17. Let's first make sure it's an arithmetic sequence. So to go from 31 to 24, what can we do? We can subtract 7. From 24 to 17, we can subtract 7. So the explicit formula is the first term plus the common difference n minus 1. So what's our first term? Our first term is 31. Our common difference is negative 7. And we're looking for the 50th term. So this time we're actually going to plug something in for n. And we're going to plug in 50. And now let's solve that. So 31 minus 7 times 50 minus 1 is 49. And if you plug that in to your calculator, you'll get negative 312. So our 50th term for that sequence is negative 312. Let's look at one final example with arithmetic sequences. It says, given the sequence defined by the function a(n plus 1) equals a(n plus 12) with a1 equals 4, write an explicit function rule. So this looks like a scary problem, but really it's just worded funny. So they tell us that our first term is what? Our first term is 4. So we're going to start with 4. Now here, they actually give us the rule for our sequence. So we can take our first term 4 and add 12 to it. So what is 4 plus 12? 4 plus 12 is going to give us 16. So our second term is 16. What is 16 plus 12? It's going to give you 28. And what is 28 plus 12? 40. Now I could keep on doing this forever and ever. I'm going to stop there. So this is our sequence. Now this looks just like any other problem we've done so far. We just have to write the rule for that sequence. So the only difference with this question is they didn't directly give you the sequence. You had to write it out using the rule that they gave you. In this case, you could find the next term by adding 12. Okay? So they want us to write an explicit function rule. So it's an arithmetic sequence, so we know it's a subscript n equals the first term plus the common difference n minus 1. And what's our first term? Our first term is 4. What's our common difference? 12. And we're not looking for a specific term this time, so we can just leave it in terms of n. And that's everything you need to know for arithmetic sequences. Now let's take a look at geometric sequences. So a geometric sequence is a sequence where each term is found by multiplying the previous term by a constant. And that constant is called the common ratio. So it's different from arithmetic sequences, because remember, arithmetic sequence we were adding a constant. Geometric sequences we're multiplying. And instead of common difference, it's called the common ratio. And the common ratio can be found by dividing any term by its previous term. So let's look at an example. It says find the common ratio of the following sequence: 8, 20, 50, 125. So it says ratio. So what can we multiply 8 by to get to 20? So the easiest thing is to take one term and divide it by its previous term. So what is 20 divided by 8? It'll give you 2.5. Now that makes sense because 8 times 2.5 will give us 20. And you could keep on doing this pattern through the whole sequence. So 50 divided by 20. It's going to give you 2.5. 125 divided by 50 will give you 2.5 as well. So for this problem, our common ratio is 2.5. Now let's find the common ratio of 1.25, negative 1.5, and 1.8. So we're going to take our second term, divide it by the term in front of it. So negative 1.5 divided by 1.25 is what? It's negative 1.2. If you take 1.8 divided by negative 1.5, 1.8 divided by negative 1.5 will give you negative 1.2. So in this case, our common ratio is negative 1.2.